There are three major classifications of substance known as acid or bases. The first one is the Arrhenius theory, the second one is the Bronsted-Lowry theory, and last but not least we have the Lewis theory. The Arrhenius acid is an acid with hydrogen in its formula that will dissociate in water to form the hydrogen ion or the hydronium ion in the solution. Let's have a look at the dissociation of the nitric acid in water. The dissociation of the nitric acid in water will form a hydronium ion. The presence of the hydronium ion makes the solution acidic. It is known that the hydrogen ion cannot exist alone in water. Rather, the hydrogen ion will exist in a combined state with the water molecule as hydronium ion. But in practice, the hydronium ion is customarily referred as the hydrogen ion. The formation of the hydrogen ion in the equation is written as follows. Arrhenius base is a base with OH in its formula that dissociates in water to form the hydroxide ions in the solution. For example, let's have a look at the dissociation of the sodium hydroxide in water. NaOH dissociates in water to form the hydroxide ion. The presence of the hydroxide ion will make the solution basic. Bronsted-Lowry acid is any substance that can donate an hydrogen ion to another substance, while the Bronsted-Lowry base is any substance that can accept an hydrogen ion from another substance. For example, let's have a look at the dissociation of the acetic acid in water. From the dissociation of the acetic acid in water, acetic acid is an acid because it donates an hydrogen ion to another substance to form a conjugate base, which is the CH3COO-. Conjugate base is defined as substance that remain after an acid donate it H+, while water is a base because it accepts an H+ from another substance to form a conjugate acid. Conjugate acid is defined as substance that remains after a base accepts an H+. Lewis acid is defined as any substance that can accept a pair of electrons to form a covalent bond, while a Lewis base is any substance that can donate a pair of electrons to form a covalent bond. Let's have a look at the example of the reaction of boron trifluoride with ammonia. We had learned to draw the Lewis structure of a compound in chapter 4. From the Lewis structure of boron trifluoride, we can see that on boron, there is not enough 8 electrons. So boron has an incomplete octet structure. Thus, boron can accept a pair of electrons to form a covalent bond with ammonia. So, boron trifluoride is a Lewis acid. In ammonia, we can see that there is a pair of electrons on the nitrogen atom. So, ammonia can donate a pair of electrons to borons to form a covalent bond. Thus, ammonia is a Lewis base.